Okay, so let's talk about our warm-up. I rewrote the first two equations already. So given kind of these funky setup equations, I'm just rewriting it so it's in function form, or if it's in y equals mx plus b. And my first line, you should have had a y-intercept at -1 and rise over run of 6/5. Okay, positive, so increasing from left to right. And notice like I reduced the 12/10 to get 6/5. 12/10 wouldn't fit on my graph, but 6/5 I can use on my graph. And we always want to be reducing things as we rewrite it. On our second example, I also had already rewritten this one, and my y-intercept is at -3. And my slope is -5/2, and I can't go down -5. What could I do instead? I could go up 5. And if I go up 5, but I want to keep it negative, yeah, then I need to go -2. And I can still kind of check knowing that negative lines have to go downhill or are falling from left to right. I can kind of check that, especially when I work backwards. Then moving on to the two graphs at the bottom. So what would be something I could do to get started on rewriting my equation on 3? There's a few different ways I could go about it. Yeah, sure. So instead of moving x and 12 away from y, I could just subtract 3y. So now 3y is over on the left-hand side. And then I just need to divide everything by -3. And y would equal +1/3 x minus 4. And it doesn't matter like what inverse operation you choose to go with or how you end up trying to rewrite this, you should land here no matter what. So even if you added x and subtracted 12, you still would get this as your final equation. So my slope is 1/3, y-intercept at 0, -4, 1/3. And I'm realizing that the A cohort, we haven't talked about graphing in slope-intercept form over Zoom yet. I've been working with the B cohort and the remote students, but hopefully this was something that you've been practicing at school. We're no longer using a table, right? Much faster to graph this way. And then this last graph, this would be based on the notes that I think it was yesterday where you talked about horizontal and vertical lines. So when I go to rewrite this, first of all, what's something I could do to get started on rewriting that equation? I could, again, yeah, I could move this 3y over. So if I subtract 3y, so now I have -3y equals 15. Or I could subtract 15, exactly, same idea. And then if I divide by -3, now I have y equals -5. So this is the type of line, I call this a HOI, a horizontal line, 0 slope, y equals a number. So my slope is 0. My y-intercept is at 0, -5. I don't even really need to think about this stuff. As long as I know it's a horizontal line and I know what horizontal means, I find -5 on the y-axis. Okay, y equals -5. So on y, find -5 and know that I'm drawing in a horizontal line where y is -5. And if it was x equals a number, then I'm drawing in a vertical line where x equals that number. And that's what our notes were on yesterday. And so let's talk about homework. I'll give you the key to the homework. You had some of these graphs also in your homework last night, yeah. So the first 6 graphs are up there if you want to just check. And then if you want to go over any of them, we can. And then we're going to take notes after we're done with that. So have your notes packet out too. Thanks, Addie. So notes number 7, it's on page 26 of your packet, and we'll talk after the notes. We'll kind of talk about the plan for the next week. So standard form, we've been seeing equations in standard form. So standard form of an equation is when it looks like this, where we have x and y on one side equal to some value over here. Okay, so for example, maybe I have 3x subtract 4y equals 16. Okay, this is an equation in standard form. Now, what you should probably be noticing, and I don't always give you standard form to rewrite in y-intercept, like on the homework, let me just pull all the homework back. Like this isn't standard form, that's just a mess that we have to clean up. This isn't standard form. I don't even know if I gave you any in standard form yesterday. As we started, you would have seen more. So like on homework number 15, the whole first page, I think, was in standard form. And that's a pretty like typical way to present an equation. And then many times we rewrite it in y equals, and we can say our slope and y-intercept. That's honestly what I do, because I also, we're like, who's familiar enough with this without rewriting it, you could tell me what the slope would be because you noticed a pattern when equations look like this, or you can move it kind of in your head when it's set up like this. What would the slope be for this line? Three-fourths, right? Yeah, so I'd subtract 3x and then I'd divide by -4, so that negative over a negative would make it a positive. My slope would be 3/4 here, and my y-intercept would be what? -4, yeah. And so like I've rewritten an equation enough to kind of see how this works time after time, and I can look at that and say what the slope and y-intercept is, and for me it's just faster to graph that way. And that's always going to be true. So like if I look at this general form, my slope here, it's always -a, negative whatever values in front of x, or the opposite of whatever values in front of x, over b. So if I think of this example, -3 over -4, that's how I got my slope. And b is always found by taking c, this number here, and dividing it by the number in front of y. Okay, and that's like a pattern that many of us have noticed, and I think it's faster to graph that way. But there's also other methods that are pretty efficient in graphing. So I'm going to start by talking about the y-intercept because we're familiar with the y-intercept. The y-intercept is when x equals 0, or when the graph crosses the y-axis. Okay. So if I have a line, I'm going to have that y-intercept somewhere on that line. It will hit the y-axis and give me my y-intercept. Now the key here when we're in standard form is this piece, is that wherever it's crossing the y-axis, that means that x is 0. Okay, so one way that I can find the y-intercept is to make x 0, and then I can just solve for y. And it's also pretty quick to do that when it's in standard form. So we're going to look at that in a minute. Now, if the y-intercept is when x is 0, what do you think the x-intercept is? When y is 0, exactly. When y equals 0, or when the graph crosses the x-axis instead of the y-axis. So if I draw kind of the same line as I did before, okay, this is my x-intercept, whereas this would be my y-intercept. Okay, so my graph is hitting the x and the y-axis, giving me an x-intercept and a y-intercept. Of course, instead of, the only time that we wouldn't have an x and y-intercept is if we have those special Hoy or Vux lines. That's just going to either hit the x-axis or just hit the y-axis. But if I have a line that has a b and then a slope, it's going to eventually hit the y-axis somewhere and eventually hit the x-axis somewhere. And so we'll have both of those values. And again, this is the key when we talk about maybe graphing these a little more efficiently, if this isn't quick for you to do. So given an equation in standard form, and I want to emphasize this is only in standard form, not like all the other funky forms that you had on homework 16 last night. Just if it looks like this. So option number 1 is do exactly what we have been doing, which is rewrite it in graph and slope intercept form. And so if I were to rewrite this standard form equation, it would be y equals what? What would my new equation be? (2x), yeah, positive 2x, because I'd subtract 4 and then divide by -2 and subtract 4. And so I'm graphing using the fact that my slope is 2 and my y-intercept is at 0, -4. So I go 0, -4, rise of 2, run of 1. And there's my line. Okay, pretty fast to do a graph that way. Now we're going to graph the same equation using intercepts. So what that means is I'm taking this same equation, 4x minus 2y equals 8. And I call this the cover-up method. You never have to use this, by the way. If you want to graph this way, great. You can graph a line. I'm happy with that. This is just to show some of you who may want to get faster with graphing. Maybe this is faster for you to do versus this. It's really just a choice. That's what we're talking about today. I have a few choices on how I could get the correct graph here. So we have two intercepts. So we have our x-intercept and we have our y-intercept. Our y-intercept we know is when x is 0. We're going to find a value when x is 0, what is y? Our x-intercept is when y is 0. We're going to say, well, what's x when y is 0? And so I call this the cover-up method because what happens when I plug in, like for this first one, when I plug in 0 for y, well, -2 times 0 is just 0. It zeroes out. And so what I do is I just cover it up. And I say, well, if I zero out y, then it leaves me with 4x equals 8. And I just need to divide by 4, and I would know that x equals 2. So my x-intercept is at 2, 0. To get my y-intercept, I just cover up x, and it gives me -2y equals 8. And what would the y-intercept be? -4. Okay, that's why I call it the cover-up method, because it's like I cover up one, zero that out, get the other, zero this one out, and get my other intercept. And now instead of using slope and y-intercept, I'm just thinking about it differently. It's almost kind of like a table. Like, okay, I have these 2 points. So I'm going to plot these 2 points, 2, 0, 0, -4. I only need 2 points to draw a graph. So here is my graph. They look a little different because my graph's a little off here. I should have done a better job. Look how off my graph is, even with a ruler. That's horrible. Okay, because it was 2 over 1. This line should really be more like this. I mean, the ruler must have been tilted a little bit. Lines aren't super accurate with just 2 points, to be honest. Like, look at that. That was way off. Because look how much my ruler can tilt. So here's those 2 points. I'm still touching those 2 points. I'm still kind of touching those 2 points and still the other way. That last one was more closer together. The closer together the points are, the more I can kind of tilt between them. So I didn't do a great job showing that this is the same line, just different way of getting it. Using slope and y-intercept to get it, or just finding the 2 points, 2 very specific points that are easy to find and graphing that way. Okay, it's still the line. What I ask is that when you do like a quiz or a test, that you give me whatever information you use to graph. So like, here's the line, how did you graph it? What did you use? So you're either going to write these points or write the slope and y-intercept so I know how you got the graph that you had. Because that helps me, like if you wrote 0, 4 up here and then you went 0, 4 and your line's backwards, I would know that this was the issue, not that you didn't know how to graph, you just lost a negative there. Okay, so some piece of information somewhere along the way. All right, so flip this over. So we're just going to practice this. just to see if you like it. Yeah, it's always going to work. It's just like a table. You're finding two specific points. Okay, and it will always give you the right graph. It'll only work if your equation looks like this in standard form, where I have x, y equals a number. And again, like I said, it's just a choice, but it's somewhat efficient. It's pretty efficient. And, you know, some of you may love it. Some of you may be like, why? I can rewrite in y equals in a second. So I'm just going to do that. That's fine. But what we're going to do is go through 6 graphs and just kind of get the feel of it. And then you can choose to graph things like this however you want. Okay. So if we're going to graph and it says specifically using intercepts, then that's again what I call the cover-up method. Hold on, I have a waiting room. So I'm going to, and I like to write my points out. So 0x and 0y. That's the 2 points I'm going to find. If I zero out x, which is this first point, if I make x 0, then what's y going to be? -2, because I'm going to divide by -5. And if I zero out y, then x is going to be 10. Yeah, nothing to divide by there. Oh no, that's not going to fit in my graph. We'll do the best we can. So I go 0, -2, and then I have 10, 0. So 6, 7, 8, 9, 10. There's my x-intercept and my y-intercept. And I connect them. And there's my line. Now, if I had used slope and y-intercept, I would have had a y-intercept at -2 and a slope of 1/5, which would have just given me that point instead. Same line, different way of getting there. Using the cover-up method on number 2. So I go, okay, that's an equation in standard form. What if x was 0? Well, then y would equal 4. If y was 0, now this one gets a little tricky. What would x equal? 2/3. Yeah, exactly. 4/6, which reduces to 2/3. So I go 0, 4, and 2/3, 0. So here-ish. Now, and that's part of the reason I don't love this method either, is graphing a point that's a fraction is definitely an estimate. Whereas using slope, that's a fraction a lot. That's not an estimate because I'm counting even units all the way up, but it does pretty well. Like if we think about my slope would have been -6, so I would have been -6/1. Okay, so if I had graphed this using slope y-intercept, I would have gone 0, 4, -6/1, and my point just would have been there. Same line. On 3, we are again, I think, going to get a fraction. I tried to make sure that I did that on here a few times so that if you are committed to this method, which some kids are, like so some students just love using this method when it's in standard form, and that's fine. But part of that commitment is knowing that intercepts are not always perfect numbers. The y-intercept many times is not a fraction because equation editors give us nice equations to graph and slope y and y-intercept. So many times the x-intercept becomes a fraction when you use that method, which again is fine. We just did it and we were really accurate actually. -6/1 hits that line perfectly in terms of what the slope would have been. But you need to be prepared for, you know, dealing with some fractions. No, if you use the cover-up method, so somebody just asked me, if I use the cover-up method and my line's off a little bit because my points are fractions, will I lose credit? No, as long as you've given me that information. So like, as long as I know you're using intercepts and I can see you used intercepts and the intercepts are correct, they happen to be fractions, and then the points you graph represent those fractions, that's okay if your line's off a little bit. When we do get to the next unit, which we'll be doing new stuff the week before Thanksgiving, we graph systems. When you graph a system, that means you graph more than one line, and you do want those lines to be really accurate because you're trying to figure out where they meet. And so using intercepts would be fine. If you have a whole bunch of fractions, though, you may go against it and use slope and y-intercept instead. But no, in terms of me grading your line, as long as I could see what you used and you plotted it correctly, that's fine. So why does the cover-up method work? Well, there's many ways to graph a line. So we started with equations just like this, and we made a table. Realistically, somebody needs the attendance link. This is a table. That's all it really is. It's just a 2-point table where I'm saying in my table, instead of just having inputs, I'm saying when X is 0, find Y. When Y is 0, plug that in and find X. Really, that's all we're doing. So when we started graphing at the beginning of unit 2, like a week ago or a week and a half ago now, or whenever we started with a table. Then we talked about slope and we said, well, it's much faster if, since we know y equals mx plus b, it's much faster to go b, use our slope, graph our line. This is just kind of, in a way, it's almost going back to a table, but choosing strategic points. Okay, so there's infinitely many points on a line. We can use points, we can use slope and y-intercept. It's just another choice. Okay. So on this one, if I cover up X, what's my y-intercept going to be? -4. And if I cover up Y, I get 8X equals 12. Yeah, so that's going to be 12/8, which we can reduce to 3/2. So I go 0, -4, 3/2, 0. So 3/2 is going to be between 1 and 2. And really, when I do use slope and y-intercept, which again, full transparency, I don't use the cover-up method. I'm pretty quick at knowing my slope and y-intercept, and I like the consistency of it because it works for every equation, not just standard form type of equations. So just any equation, I get the slope and y-intercept on. That's how I choose to graph. If you like this, that's fine. But really, when I'm doing slope and y-intercept, the y-intercept is a point, and I'm just using slope to find another point. We're just finding that other point differently here. On 4, when X is 0, Y would be -3. So there's my first point. When Y is 0, X would be 1/2. 0, -3, 1/2, 0. Again, that's one with a pretty steep slope. My slope would have been 6. So let's just see how accurate we were. I'm off a little bit. So 0, -3, if I had gone 6/1, I'm not bad. Then I would have hit this point instead. Okay, but again, slope's just finding a different second point that's on that same line. So now I'll be quiet and I'll let you find the intercepts for 5 and 6. I'm just going to write quietly. You don't have to look at what I'm writing. You can see if you can get it on your own and then check. Okay, so I have my intercepts. So see how fast, like, and I've had them. I've been sitting here for a minute. It's really efficient, right? Slope, I think, is equally as efficient many times, most of the time. So graphing my first one, my y-intercept I had at -1, and my x-intercept is -1/3. Those are kind of unfortunately close points. It's okay. What would I would have had -3 for slope. So my slope, if I had rewritten this, y equals -3x minus 1, I kind of kept that in my head so that I was making sure I was hitting pretty close to that point as I drew it in to make it a little more accurate. On 6, I get 0, -2, and then 8/3, so like almost at 3, 9/3 would be 3. My slope would have been 3/4, so 3/4 is here. And there's my line. Okay. I'll talk about tests in a minute. So that's that. And so you'll notice like that's the end of the packet. Like I said, today's notes, it's kind of a totally optional way that you could go about graphing those standard form lines. You don't have to. What's kind of coming up is, so we've done, I'm gonna not